Since life began 3.5 billion years ago, species have appeared, evolved, and vanished in step with the ebb and flow of environmental conditions. To unveil the beauty and fragility of nature, the oceanographic schooner Sedna 4 has set out on a mission, 1,000 days for the planet. Leading the expedition is Jean Lemire.
We set sail for the Galapagos Islands, true icons of the amazing biodiversity of our planet. Here, nature's spectacle has fascinated people for generations. Conservation is fundamental on the Galapagos, and the protection measures implemented here can help establish more balanced relations between humans and the other species with whom we share the globe.
Located more than 1,000 kilometers off the coast of Ecuador, these remote islands are among the most famous in the vast Pacific Ocean. But for centuries, the archipelago was known only to a few sailors who kept its existence secret. Back in the day, the islands were a larder for pirates. The local wildlife made easy pickings. They had no fear because there were no natural predators. Passing sailors introduced a number of animals, and these have multiplied. Goats, rats, and other invasive species still threaten the unique flora and fauna of these remote islands. But a new threat is looming, more insidious than tourism or even the introduction of exotic invasive species: climate change. The island's extraordinary richness is due in large part to the interplay of the great ocean currents that help regulate the climate of our planet. In this region, the Humboldt Current flows north from the Antarctic, skirting the coasts of Chile and Peru. This deep water stream, 7 or 8 degrees colder than the surrounding ocean at these latitudes, comes to the surface bringing nutrients that stimulate the growth of plant and animal plankton on which many species of fish feed. This abundance of food is a boon for many animals, like the Galapagos penguin, the most northerly species of penguin on the planet. The geographic location of the Galapagos Islands isn't an ideal habitat for penguins, but they've been able to adapt to the tropical climate thanks to the cold ocean currents that bathe the archipelago. To escape the heat, Galapagos penguins spend most of their time in the water and only return to land at sundown. But an increasingly frequent climatic anomaly is threatening the survival of these penguins endemic to the Galapagos: El Niño. Normally, the tropical trade winds blow the warm surface waters out to sea, creating a vacuum filled by the upwelling of these cold, nutrient-rich waters from the depths. In El Niño years, the trade winds weaken. The masses of warmer water that accumulate in the western part of the South Pacific travel east, blocking the upwelling of the cold ocean currents all along the coast. The coastal waters heat up even more and cannot support nutrients. The great schools of fish, such as anchovies and sardines, migrate further out to sea, leaving species that depend on them for food to go hungry. 2 major El Niño events in 1982 and 1997 caused a famine among the penguins of the Galapagos. In 1982, El Niño wiped out 77% of the population. Only 463 penguins remained on the Galapagos. 15 years later, in 1997, another extreme El Niño struck hard. That year, 66% of the already diminished population starved to death from lack of food within reach of the archipelago. Today, Galapagos penguin numbers have stabilized at around 2,000 individuals. However, the high mortality rate associated with El Niño means that this weather event is a major and ongoing threat to the survival of this vulnerable species. Scientists in Galapagos Islands National Park, who monitor these climate phenomena, have already noted important changes within different ecosystems.
En esta época del año, las iguanas marinas empiezan a hacer su territorio, ¿no?
This is the time of year when marine iguanas start to establish their territory.
Está agarrando su territorio. Normalmente
And these guys are doing that right now.
donde pueden tener varias hembras, si puedes ver. Y en esta época del año normalmente
They lay out the boundary of an area within which they can control a certain number of females.
Desde los últimos 4 o 5 años, personalmente he visto
Mating season begins around the 24th, 25th, or 26th of December.
estos son como un reloj.
But for the last 4 or 5 years, they've started mating later.
Y empiezan a reproducirse,
They've always
pero
been
el
as
año
regular as
pasado
clockwork.
estaba como por el mes de enero, los primeros días de enero. Y luego,
Last season, mating didn't start until the first few days of January.
También se demoró 1 o 2 semanas más. Entonces como que se fue extendiendo más el tema del tiempo, ¿no?
With mating happening later, the eggs don't start to hatch until 1 or 2 weeks later than usual. So the whole reproductive process is shifted later in the year.
Creo mucho que ver con el tema del cambio climático, con el tema del
I think climate change is a major factor in the delay in the reproductive cycle.
En Galápagos también se siente.
We're definitely feeling the effects of climate change here in the Galapagos.
La temperatura del mar se toma desde
We've been keeping track of ocean temperatures going back 70 years.
de unos 60 años que en la actualidad para el
Now
tema
that climate
del
disruptions are a
cambio
big concern,
climático,
our records are proving very useful in identifying temperature spikes during El Niño
¿Cuándo han
events.
sido los picos más altos, no? Por ejemplo, cuando hay en la época del Niño. Ok, gracias. Lo importante de estos datos es que
This data is vital over the long term. In 20 or 30 years, we'll be able to determine whether or not climate change has had an impact, something that we simply couldn't do with short-term data.
En corto tiempo, ¿no? Este animal que está aquí
This animal here is a type of sea crab that originated far away from the Galapagos archipelago. They traveled on a warm current during an El Niño event. We found lots of them here in 1997 and 1998. We had never seen them before. Their arrival allows us to deduce that ecosystems are affected by changes to the climate. And this is proof that species change, ecosystems change, but also that the habitat where the animals live also undergoes profound changes.
El Niño is unpredictable. The climatic anomaly appears every 2 to 7 years. But many scientists think that the frequency and severity of El Niño events could increase, even double, given the current climatic changes. This could prove fatal to several species endemic to the Galapagos, including sea lions, who depend on the nutritional bounty of the cold Antarctic current. Scientists have noted much higher mortality rates in El Niño years. During the last extreme event, numbers dropped by half.
We've observed that during El Niño events, the seals and sea lions have to go further out to sea to find food like anchovies or sardines. Nursing mothers have to leave their pups alone on shore for longer periods of time. The babies go without food for long stretches and eventually weaken and die. So it's the younger animals that are most seriously affected by these changes to the ecosystem.
At least 90% of the pups will die on the beaches of the Galapagos during extreme El Niño events. And it can take up to 10 years for the population to recover. If, as a majority of scientists think, climate change does increase the severity of El Niño as well as its frequency, The future for these animals, already listed as endangered, is more uncertain than ever. Climate disruptions have no borders and can have dire consequences spread over time and great distances. At the sub-Antarctic Bird Island in the southern Atlantic Ocean, scientists of the British Antarctic Survey noted major die-offs among young fur seals. And these events repeated over time. Years of research have shown that El Niño also takes a toll on wildlife in the Atlantic Ocean, but 2.5 years after the event begins in the Pacific. The band of warm water created by El Niño spreads down the coast of South America, rounds Cape Horn, and flows into the Atlantic, dramatically reducing marine productivity, forcing the fur seals of Bird Island to travel much further in search of food. It took 2.5 years for the warm waters to reach this island in the South Atlantic. But the result is the same. The seal pups starve. The beaches of Bird Island become cemeteries in turn, a testament to the deadly reach of El Niño. In the Galapagos, despite the most stringent conservation practices in the world, many species are under threat. The culprit? The climate crisis, which knows no borders and sneers at conservation measures. A rise in ocean temperature could also have irreparable consequences for the survival of these unique creatures. They have become true symbols of conservation. Marine iguanas, too, are affected by warming seas. Iguanas eat sea algae, which become indigestible as a result of a buildup of a toxin that grows in warm, humid weather. When there's nothing but poor quality algae to eat, and not even much of that, the iguanas are in grave danger. As well, erosion and floods destroy their nests, and the warmer air affects their ability to control their internal body temperature. In one of the most recent extreme El Niño events, almost 90% of marine iguanas died. Torrential rains that accompany El Niño can affect the giant Galapagos tortoise. Nests get flooded, and landslides trap some giant tortoises in ravines. Estimates are that over 250,000 giant tortoises once lived on different islands before the Galapagos were discovered in the 16th century. Caught and kept alive on sailing ship as a source of fresh meat, their numbers plummeted. The introduction of invasive animals like goats and rats also contributed to the decline of giant tortoises throughout the archipelago. In 1974, there were only 3,000 individuals left. But major conservation and captive breeding programs have allowed some subspecies to recover. Today, there are around 20,000 individual animals all told.
This is a male tortoise from Santa Cruz. We're 25 kilometers from the coast. That's why there are around 5,000 of this subspecies left. It's so far inland that the whalers and hunters never bothered coming to get them. These animals are an integral part of our ecosystem. The plants on the Galapagos have evolved in concert with this link of the chain. If it weren't for these tortoises, the vegetation would be completely different. We know that some of these plants even have to pass through the tortoise's digestive system to germinate. The evolution of the island is so intertwined with the tortoises that it's hard to imagine what the islands would look like if there were no tortoises.
Efforts to conserve the last giant Galapagos tortoises have saved some subspecies from extinction. But it was 1 minute to midnight when the reintroduction team arrived on the islands.
I started working with the tortoises when the park was created. At that time, we knew very little about the tortoises. How well was the population doing? Were they in good shape individually and as a species? Where did they come from? Where were they concentrated? We knew nothing about them.
Fausto Llerena is known around the world because of his special relationship with one famous tortoise, Lonesome George. George was the last living male of the Pinta Island subspecies. A bevy of genetically compatible females were introduced to the old bachelor, but in vain. People around the world were enthralled by this amazing story of survival. Today, Fausto Llerena and his team focus on protecting young tortoises for eventual reintroduction on the different islands of the archipelago.
The tortoises live here for 2 years before being released into the wild. They're still very vulnerable during that first year. The biggest danger is rats. Rats don't attack the eggs, just the baby tortoises. But the pigs eat tortoise eggs. Rats can actually eat a small tortoise like this. We've reintegrated 1,800 tortoises from our incubators on Hispaniola Island. At that time, only 15 adult tortoises were left. We brought them here to mate. We had to do that because they weren't reproducing in the wild. The few who survived were dispersed all over the island. It was almost impossible for males and females to find each other in all that territory. Now we are finding nests of young adult tortoises. There are around 3,000 today. The species has made a good recovery.
Conservation measures, captive breeding programs, and the giant tortoise's amazing longevity, up to 200 years, have enabled some subspecies to escape extinction. But other subspecies remain in danger, especially with the potential degradation of their habitats caused by climate change. We left the Galapagos feeling uncertain about the future of this paradise of biodiversity. Climate change will affect not only animals and plants over the next century. Scientists foresee that all the islands in the Pacific will face temperature increases on land and sea. Beyond the disasters feared by the predicted rise in sea level, ocean warming could affect our ability to feed the planet. To understand one of the little-known consequences of warming, we set sail for French Polynesia. Spread over 165 million square kilometers, 1/3 of the surface of the Earth, the Pacific Ocean supplies almost 60% of all the fish eaten on the planet. This extraordinary abundance is due in large part to its coral reefs, which support a wealth of diverse life forms. But over the last 30 years, scientists have noted a dramatic rise in coral die-off and an overall degradation of coral ecosystems. All over the world, coral reefs are threatened by the warming of the oceans, by their increasing acidity, and by the ever-growing pressure of humans on these fragile habitats. On the island of Moorea, scientists are working to understand the evolution of coral reefs.
In a way, it's a shame that coral reefs are coastal. Coral needs light to grow, so they have to be in shallow water, which automatically puts them close to human activity. The biggest threats are overfishing, excess sediment, drag nets, and hard objects that bump or crash into the coral reef. All those things have a negative impact.
Coral reefs form ecosystems that provide shelter and food to millions of life forms, from bacteria to algae, and from fish to the largest marine predators. Reefs are comparable to tropical forests on land because of the amazing variety of species that depend on them. Coral reefs are fundamental to life in the oceans. Degradation of corals will inevitably impact how much fish the oceans can produce. We estimate that more than 85% of fish stocks are overexploited or exploited to the maximum, and the pressure to feed humankind can only increase. Yet, according to the Food and Agriculture Organization of the United Nations, 7 of the 10 most important varieties of fish are on the brink of complete disappearance. Globally, 1 fish species in 3 is threatened with extinction.
We've been recording ocean temperatures on Moorea for over 25 years and have noted what may seem like a slight increase of 1/4 degree Celsius. This long-term study indicates a trend, and if we're talking 1/4 degree every 25 years, that's 1 whole degree in a century. We're starting from average temperatures of 28 to 29 degrees, and 1 degree more takes us up to 30 degrees, just about the upper limit of tolerance for a coral reef. That's when bleaching starts to occur, and any additional stress could tip it over the edge. Each stress isn't disastrous in and of itself, but it's the accumulation of stressors that does the damage.
Even a small increase in temperature is highly stressful to corals. Corals react by expelling zooxanthellae, single-cell algae that live symbiotically with the coral. Without these essential algae in their tissues, the coral turn white and will eventually die of starvation. Episodes of massive coral bleaching have been observed 7 times since the middle of the 1980s on the Moorea Reef. Coral reefs are also vulnerable to attack by the crown-of-thorns starfish, or Ocanthaster. This voracious coral-eating predator has caused the percentage of living coral on the north coast of Moorea to plummet by 96%. Another blow fell in 2010, when Cyclone Oli's 7-meter-high waves heavily damaged the physical structure of the outer slopes of the reef, leaving the coral in a critical state. But the coral ecosystems of Moorea seem resilient. Doctoral candidate Caroline Dubé is studying the Moorea Reef.
On the dive, we saw a lunar landscape, indicating that the reef has been badly damaged in a series of disturbances over the last decade. We can't say for sure that the reef is recovering, but some pioneer species are starting to recolonize the substrate. So that's a good sign that things are starting to get back to normal after all the upheaval. And as we continue to observe the reef over the next few years, we should gather more evidence of the reef's chances to make a full recovery from the damage. Today we saw herbivores, carnivores, and large predators like sharks. That shows that the food chain is intact, despite the fact that the coral isn't in good shape. It proves that the ecosystem is stable and that there's a chance that it will recover over the next few years.
While the number and variety of life forms in and around the degraded coral reef has diminished considerably, there is still a wide range of species in the food chain. The arrival of large predators may be a hopeful sign for the future of this recovering ecosystem.
So he's a juvenile? How old?
He's just under a year old. He's about 60 centimeters long. Now we've got him, and we'll try to be quick, get everything done within 1 to 3 minutes. Let's go. First, a picture. That's one. Can you turn him over? What we've been doing for the past 2 years is collecting data on juveniles, subadults, and adults. And by recapturing individual animals, we can see how fast they grow. And he's a bit more, 3.6.
And the young sharks will stay here for 3 or 4 years?
That's right. They live here and eat, get bigger and stronger. Once they become subadults, when they're around a meter long, they'll start to travel more out into the lagoon and even to the other side of the reef. There, he's ready to go.
Research is vital if we want to improve our understanding of the complex universe of reefs.
Good morning.
American scientists from the University of California are studying the recovering corals near Moorea.
Good morning. Good morning. How are you? Welcome on board.
They're taking advantage of Setanophores' presence here to expand their exploration into harder-to-reach areas in order to compare the different rates of coral recovery.
Coral reefs are really in a very dire situation. Large amounts of coral have been lost in the last 50 years, and that loss of coral arguably began 300 years ago when European explorers first got to tropical locations. But those losses have really intensified in the last 50 years, and maybe in the 60s and 70s there are many parts of the world that had half of the seafloor covered by live coral, and now it's barely 1/10 of that. It really is very serious.
Scientists are investigating the way new coral tries to repopulate these places. What varieties are resilient, and what are the chances that someday we'll see a viable ecosystem established despite the predicted climatic stress?
So our main objective is this coral survey, and really the tool is the camera framer. So we're looking at the whole landscape, but we're taking very detailed pictures of just a ½ meter by a ½ meter. We're repeating that many times, and we'll do that at a series of depths, and from that we can then put together a detailed picture of the community structure of the corals.
These are the coin of the realm for our trade. These are photographs of the seafloor, and we have similar photographs that go back now 9 years for Moorea. And we use these photographs to measure how much of the floor of the reef is covered by live coral and how much has died.
How was it?
Oh, really good. You know, it's a really interesting place. It's, I think it's been not as disturbed, or maybe it's been longer since the disturbance than over on Moorea. So we saw more corals, a little bit older corals, so you can see a lot of coral competition. Down deep, it was kind of a lot of rubble, but also a lot of juvenile corals growing in. So it's a sign that there's recruitment of new corals coming here.
This little colony down here, this is live stony coral. This is the coral that probably, it's either unhealthy or it has died recently. And all this gray stuff around here, this is reef rock colonized by algae. So only about 5% of that table is live coral, and the rest is algae and reef rock. So here is a coral colony that was eaten by crown of thorns probably within 48 hours, and here is another one. And just for the contrast, this is what they should look like when they're healthy, just a beautiful layer of tissue, and that disappears, and we have this whiteness.
Even if the result of that is white, it's very different from the bleaching problem.
Absolutely. It's a common symptom of two very different conditions. One is where the tissue is removed and you're seeing the white bones sticking up into the water column. The second one is where the corals typically are stressed physiologically, usually because the seawater is very, very warm. It causes them to lose their symbiotic algae that they feed with. Once those algae have gone, the tissue is a very thin, transparent layer for a short period of time. And it's white. It looks just like this. But the difference is, for that short period of time, they remain alive. However, without the algae, they can't feed off sunlight. So they then slowly starve. And if the water stays hot, they starve and they starve. And usually within about 2 weeks, then the tissue will die. And then we're back to this condition where whiteness is a sign of the bare bones in the water column.
If we look at the condition of coral around the world, a good 20% of the world's coral is permanently destroyed. These numbers are approximate. Then we have 50% of coral that is critically endangered, and the remaining 30% is in a relatively natural state and not under any particular negative stress for the moment.
Some scientists believe that over 60% of corals could die by the year 2060. Yet fish are the primary source of protein for over 1 billion humans.
The main problem is overfishing. And that's happening because coral reefs are located in economically disadvantaged areas where countries are poor and overpopulated. There's a population explosion in Southeast Asia, throughout the Pacific, as well as in Africa, which is increasing the already tremendous need for protein. And there's a big food warehouse on the doorstep, the lagoon. So people keep on harvesting the way they did in the old days. But whereas there used to be 2,000 fishermen, now there are 20,000. So sooner or later, the system will not be able to produce enough to meet demand. With regard to current climate changes, we know that some corals will be unable to adapt to a rise in temperature or acidity. But there are a great many varieties of coral, and some that are not dominant today could well become dominant in the future. The king will be deposed, and other species of coral will become the main builders of the ecosystem. What we don't know is what that ecosystem will be like. To say there will no longer be any coral ecosystem is going too far, in my opinion. Coral reefs have existed since the dawn of time, so it's a bit much to suggest that they'll disappear. But that they will change, that the balance of the reef system will be modified, of that much I'm sure.
Predictions on climate change include an increase in ocean temperatures. So it's crucial to understand how coral reefs will react in these new circumstances. What types of coral will best survive climate change? And how will higher levels of acidity of the oceans affect the planet's coral? Trying to paint a picture of the future is a major challenge for scientists.
This is where we've been working long hours for 6 weeks now. My graduate students and I are investigating ocean acidification and climate change on corals and algae.
So what do we have here?
We have a set of tanks. They hold about 150 liters, and some of these tanks are basically showing us what the future might look like. We're trying to create a world that will happen in about 100 years in these tanks with high carbon dioxide levels. And then we're trying to grow corals in those conditions for 6 weeks, 4 weeks to 6 weeks, to see how they respond to those conditions. We've been working on that now for about 2 years, and we have a pretty good idea of how much their growth rates will be reduced.
The outlook isn't promising. In very conservative simulations of the kind of warmer, more acidic ocean conditions predicted for the future, there's a marked decrease in coral growth and productivity. For fish and other organisms that depend on corals, it's not good news. Climate change, more frequent extreme climatic events like El Niño, pollution, the feared increase in natural disasters, and the degradation of coral reefs around the world are interconnected factors that threaten global food supplies.
Did you catch that today? Yes.
Will communities that depend on fish for survival be able to adapt to the expected drop in the productivity of our oceans? Urgent change is essential if we hope to reduce the pressure on our marine resources. Estimates are that more than 85% of fish stocks are currently being overfished or exploited to the limit. In other words, we're now harvesting more fish than the ocean can provide. If the trend continues, commercial fish stocks are likely to collapse by 2050.
The increase in the human population living by the sea is worrisome. As things stand today, coral reefs simply cannot produce enough to meet the protein requirements of an ever-growing number of people, so overfishing is inevitable. At some point, we're going to have to introduce measures to help the natural systems along if we want them to produce enough. We'll have to supplement them with fish farming, impose certain regulations, and introduce stringent management methods. But even if, as an example, we can get people to stop harvesting the top fish in the food chain and switch to species that are lower down, in the long run, we'll still be removing fish and weakening the system no matter what. So in my opinion, we need to find other types of management for better conservation.
On our round-the-world expedition, we've collected clear evidence of major changes in all marine ecosystems on the planet. Climate change risks reducing the ocean's productivity, but we will put more and more pressure on our oceans to feed ourselves. There will be fewer fish for the growing numbers of people who depend on them. In the long run, it's a losing proposition for the fish or for us, humans.
Back when pirates stopped at the Galapagos to catch giant tortoises, the idea of depleting resources never crossed anyone's mind. Why would it? At the time, there were only a few 100 million people on the planet. But in 35 years, we'll be up to 9.7 billion, and probably 11 billion by the end of the century. The pressure on global resources will continue to grow, crippling the planet's ecosystems and endangering all those who live in them. There's one species we won't have to worry about anymore. The Pinta Island tortoise is extinct. Lonesome George, the last living male of his subspecies, has died, wiping out millions of years of evolution in one stroke. More species are going extinct than ever before as a direct result of our unsustainable exploitation of the planet's resources. But all that could change. The fate of the planet rests in the hands of one species only, ours.